Welcome to the session of finite element method. In this session, I will going to discuss about strain displacement relations, my dear friends. Now, before entering into this concept, we must revise some of the basics that are already studied in strength of metal. The first one is normal strain or linear strain. That is equals to change in length of the member to original length of the member. That is equals to final length of the member minus original length of the member divided by original length of the member. That is equals to final length is represented with LF, original length is represented with LO divided by original length LO. Now, coming to our actual concept, this is x-axis direction, this is y-axis. Now, consider a differential element A, B, C, D. When force is applied for this differential element, it becomes A dash, B dash, C dash, D dash. Consider a line element AB of length dx, original length dx in x-axis direction. So, the line element AD in y-axis direction dy. Okay. Now, I am applying force in x-axis direction, my dear friends. So, because of that force, the A is displaced by U, but B is also displaced by how much? So, first of all, the B is at a distance dx more than A. So, for 1 unit displacement of B is equals to dou U by dou x. For dx distance displacement of B, that is equals to, for dx units, the B is displaced by dou U by dou x into dx. Yes, my dear students. But B is displaced to B dash by how much? But higher value. But how much? So, that is the higher value, this much higher than A. That is U plus dou U by dou x into dx. Excellent, my dear friends. So, from here to here, what is the distance from here to here? The total distance of line element is dx. You subtract from here to reach U, that is dx minus U. Okay. This length is a final length of line element A dash B dash. Excellent, my dear friends. Now, I will use different color here. So, A is displaced by V in y-axis direction, but the D is also displaced to D dash. Consider similar manner. For 1 unit displacement of D by dou V by dou Y. For dy distance, D is displaced by dou v by dou y into dy. See, my dear students, the d is higher displacement than a by this much, that is dou v by dou y into dy. So here is the displacement of d is given by v plus dou v by dou y into dy. So here is the final length of the element a dash d dash, that is equals to this one. But what is the distance from here to here? Here to here is distance, that is already found here. Similar fashion here also, total length is dy. You subtract from that v, that is dy minus v. Now the final length of the line element a dash d dash is equals to dy minus v plus dou v by dou y into dy. Excellent, my dear students. Now coming to what is a normal strain. First of all, in x-axis direction, normal strain or linear strain in x-axis direction. In x-axis direction is given by epsilon x, that is epsilon x is equals to final length of the line element a dash b dash minus original length of the line element a b divided by original length of the line element a b. See, my dear students, this is original length of the line element is a b. This is u plus dx minus u plus dou u by dou x into dx. This is final length of this element a dash b dash, line element a dash b dash. Now that is equals to, so I will write here, so final length, that is du minus u plus dou u by dou x into dx. This is the final length minus original length of the line element is a dash, original length of line element ab is equals to dx divided by original length of the line element ab, that is dx. So this one and this one cancel out here. So sorry, this is dx. So this is dx, my dear student. This is dx. Now this is dx. Sorry, this is dx. That is equal to dx plus dou u by dou x into dx minus dx divided by dx. This dx and this dx cancel out. That is equals to dou u by dou x into dx divided by dx. This dx cancel out. That is epsilon x is equals to dou u by dou x. That is strain in x-axis direction is dou u by dou x. Similar fashion, my dear students, similar fashion, normal strain or linear strain in y-axis direction. Y-axis direction is given by epsilon y, that is equal to epsilon y. Similar fashion, final length of the line element. See, my dear students, this is a final length of the line element. This is a final length of the line element a dash d dash, a dash d dash. Original length of the line element is AD is a dy. So that is LF minus LO divided by LO. That is equals to, here is dy minus V plus dou V by dou y into dy. This is a final length minus original length is nothing but dy divided by dy. This plus v minus v cancel out, so that dy plus dou v by dou y into dy minus dy divided by dy. This plus dy, this minus dy cancel out. So finally you will get dou v by dou y into dy divided by dy. This dy cancel out. So that strain in y direction, that is epsilon y, is equals to dou v by dou y. Excellent, my dear friends. Suppose when two-dimensional object becomes to, when 2D object becomes to 3D object, at that time there is a displacement in z-axis direction, so that there is a displacement in z-axis direction. That is, the displacement z-axis direction is W. Now at this time, strain in z-axis direction is equals to dou W by dou Z. These are the linear strains. Now all of it clear, my dear students. Now coming to shear strain. First of all, so what is a shear strain? We will discuss here. First of all, what is meant by shear strain? What is a shear strain? That is represented with the letter gamma. So for one-dimensional object, the shear strain, see, this is a one-dimensional case. When force is applied only in one direction, now this becomes to be like this. So this original object, this is a original object. This original object is distracted to this one. Now this is angle is alpha. This angle alpha is called as shear strain. So that is change of angle measured in radians. Is called shear strain. It is when force is applied only one direction. This becomes to be distracted like this. So this change of angle between these two, that is nothing but shear strain. For two-dimensional case, now here like this. Now force is applied x-axis direction and y-axis direction. Now it becomes to like this. Okay. So now here is angle is alpha, here is angle is beta. Okay. Now there is a change of angle between the two mutual perpendicular planes. My dear students. Okay. Now that is alpha plus beta. This is called as a shear strain in two-dimensional case. That is change of angle measured between two mutual perpendicular planes. That is called shear strain. That is called shear strain, my dear students. Now coming to shear strain here. Now this is x-axis direction, x axis, this is y-axis. X-axis direction displacement is v, y-axis direction displacement is v. Now consider this is a B, C, D differential element. Now I am applying force here. Now I am applying force this direction and this direction. Because of the force, shear force, this differential element A, B, C, D becomes to be A dash, B dash, C dash, D dash. Yes, my dear students. Now we are already found this one. What is the A dash B dash final length? This A dash B dash final length is nothing but dx plus dou u by dou x into dx. Okay. Now consider this one. After application of the force here, now this becomes to be, this line becomes to here. So this is original place of line AB. After application of the force, this AB line becomes to be A dash B dash. Now 1 unit displacement in y-axis direction is dou v by dou x, because the point A, it is displaced in y-axis direction also. This is displaced in y-axis direction. For 1 unit distance, dou v by dou x. For dx distance, it is displaced to dou v by dou x into dx. Now this becomes to be dou v by dou x into dx. Excellent, my dear students. Yes or no? Now this angle is alpha. Similar case here also. It is a original. After deformation, it becomes to be this one, that is A dash D dash. Now this is beta. So the displacement for 1 unit displacement in x-axis direction, that is dou u by dou y, dou u by dou y. For dy distance, now this is displaced to here, this is displaced to here, that is dou u by dou y into dy. Now this is dou u by dou y into dy. But this is already calculated in previous class. This is final length. What is this, my dear students? Dy plus dou v by dou y into dy. This is final length. Okay. Now, so what is our definition? Change of angle measured between the two mutual perpendicular planes. So what is the change of angle? Originally here is 90 degrees. After deformation, 90 minus alpha plus beta. This is called as shear strain. Change of angle measured between two mutual perpendicular planes. This is what one plane before application of the force. After that it is displaced to like this. So what is the change of angle between the two mutual perpendicular planes? That is called as shear strain. So now this direction it is displaced by alpha. This direction it is displaced by beta. So shear strain is nothing but, so in y-axis direction alpha, x-axis direction is beta angle. Now, so tan alpha is equals to, from this, what is the tan alpha? Tan alpha is nothing but, this is opposite side, dou v by dou x to dx. This is adjacent side. I am considered this is a b double dash. So from this triangle a dash, b double dash, b dash, what is tan alpha? Dou v by dou x, dou v by dou x into dx divided by dx plus dou u by dou x into dx. Now dou u by dou x is a smaller term. Again multiplied with the smaller term. Again you will get a smaller term. We are neglecting this term. Okay. For small angles, tan alpha is equals to alpha. That is equals to dou v by dou x into dx divided by dx. This dx cancel. Now alpha is equals to dou v by dou x. Excellent, my dear students. We are finding alpha. Similar fashion, tan beta is equals to, all of you see, my dear students, this is d double dash. From this triangle a dash, d double dash, d dash, this is opposite side, that is dou u by dou y into dy. So this is adjacent side. So that is equals to dou u by dou y into dy divided by dy plus dou v by dou y into dy. All of it clear, my dear student? See, dy plus dou v by dou y into dy. This is dou u by dou y into dy. This is opposite side. This is adjacent side for this triangle. My dear students. Now, dou v by dou y, it is a smaller term. Again multiplied with this one, it becomes to be smaller term. We are neglecting this term. Okay. So for small angles, tan beta is equals to beta. So that is, for small angles, tan beta is equal to beta. That is equals to dou u by dou y into dy divided by dy. This dy cancel out. Beta is equals to dou u by dou y. That is shear strain in xy plane, my dear students. It is a xy plane. That is shear strain. That is gamma xy is equal to alpha plus beta. Shear strain in xy plane, my dear students, that is equal to strain between two mutual perpendicular planes. That is change of angle between two mutual perpendicular planes. That is alpha plus beta. That is equal to dou v by dou x plus dou u by dou y. All of it clear, my dear students? So how to remember this formula? That is very important. So similar fashion, now we are finding shear strain in xy plane. That is, write down, x direction displacement is u, y direction displacement is v. Yes or no? So this displacement is in y direction. Write down that one here, dou y. For this displacement, u is a displacement in x direction, write down that one here, put plus here. Excellent. Similarly, suppose if it is a two-dimensional object becomes to three-dimensional object, 3D object, that is three-dimensional object. At that time, there are additional two shear strains comes into the picture, that is gamma yz, gamma zx. So similar fashion, so whatever the shear strain written here, similar fashion for these two shear strains also I will write here. So gamma yz is equals to, so in y direction displacement is u, z direction displacement is w. Divide here, draw a line here. So this displacement w is in z direction, write down that one, dou z plus here. So this u is a displacement in, so y direction displacement is v, this is v, this is v, y direction displacement is v, y direction displacement is v, so z direction displacement is w. So this displacement is z direction, write down dou z here. This displacement y direction, write down dou y here. Similar fashion, so shear strain in zx plane, that is equal to, in z direction displacement is dou w. So x direction displacement is u, that is write down dou u. So draw a line here, So this u displacement in x direction, write down that x is here, dou x. W's displacement is z direction, write down that z differential z, dou z here, put plus here. Okay. So in finite element method, so strain is nothing but there are 6 terms, that is 3 normal strains, that is epsilon x, epsilon y, epsilon z, 3 shear strains, that is gamma xy, gamma yz, gamma zx, whole power transpose. Okay, we know epsilon x. What is epsilon x? Dou u by dou x. What is epsilon y? Already derived here, dou v by dou y. What is epsilon z? Dou w by dou z. Similarly, what is gamma xy? Gamma xy is equals to, here is u, here is v, that is y direction. Write down, this is displacement y direction, write down that dou y here. This is displacement x direction, write down dou x here, put plus here. Now gamma yz, similar fashion, y direction displacement is v, z direction displacement is w, write down like this, put plus in between this. So this displacement is z direction, write down dou z here. This displacement is y direction, write down dou y here. Yes. Now gamma zx is equals to, here is z direction displacement is dou w, x direction displacement is dou u. So write down like this here, put plus in between this. This displacement is z direction, write down dou z here. This displacement x direction, write down dou x here. So there are 6 terms here. In case of 3-dimensional object, there are 6 terms. six strain terms, that is in that 3 normal strains and 3 shear strains, that is epsilon x, epsilon y, epsilon z. These are all normal strains. Gamma xy, gamma yz, gamma zx are shear strains. This is for 3-dimensional objects. So it is a strain and displacement relations. Strain and displacement relations for 3-dimensional objects, my dear friends. All of you clear? So thank you.